This is section 7.3b, continuing with multivariable linear systems. So today we're going to talk about applications of multivariable linear systems, and one application is called curve fitting. So here's the problem. Find a quadratic equation in the form y equals ax squared plus bx plus c that passes through the points -1, 3, 1, 1, 2, 6. All right, so you'll recall from last year that ax squared plus bx plus c equals y is simply one of the forms of the quadratic equation. And the curve is a parabola. That particular parabola passes through these 3 points, -1, 3, 1, 1, 2, 6. So here's how to set it up. We set it up as a system. And this is the system. 3 equals a times -1 squared plus b times -1 plus c. All right, where did that come from? Well, we know that the point -1, 3 is on this curve. And we also know that the quadratic equations of the form y equals ax squared plus bx plus c. So since -1, 3 is a point, and -1 is the x-coordinate, 3 is the y-coordinate, well, I put in 3 for y. That's why I have 3 equals. And then I have -1 that I plug in for x. And so looking at the first row of this system, 3 equals a times -1 squared plus b times -1 plus c. So we can see that all we did is we plugged in the x and y value for that first point. And we plug that into the general form of ax squared plus bx plus c. We did a similar thing for equations 2 and 3 in this system, or row 2 and row 3. And you can see that, for example, row 2, x-coordinates 1, y-coordinates 1, and that's why it's 1 equals a times 1 squared plus b times 1 plus c. And in row 3, x-coordinates 2, y-coordinates 6, so 6 equals a times 2 squared plus b times 2 plus c. Now, these equations we simply wrote taking information that was given us in the problem. Now we can rewrite this in the following way. A minus b plus c equals 3. A plus b plus c equals 1. 4a plus 2b plus c equals 6. And this is clearly a multivariable linear system. Take a moment just to make sure you understand how we got from the system on the left to the system on the right. We simply evaluated everything and rearranged terms. It's mathematically the same. All right, so now we have a system that we can solve. So take a moment now to do this on your own. Pause the video and resume when you have an answer. Okay, walking through the steps of solving this multivariable linear system using Gaussian elimination. We start by multiplying row 1 by -4. Then we are going to get this system, which is -4a plus 4b minus 4c equals -12, a plus b plus c equals 1, 4a plus 2b plus c equals 6. Then we add row 1 to row 3 because we want to eliminate that a term. And we end up with -4a plus 4b minus 4c equals -12, a plus b plus c equals 1, 6b minus 3c equals -6. Okay, now we multiply the second row by 4, and we end up with -4a plus 4b minus 4c equals -12, 4a plus 4b plus 4c equals 4, 6b minus 3c equals -6. Next we add row 1 to row 2 because we want to eliminate that A term from row 2. And we get negative 4A plus 4B minus 4C equals negative 12, 8B equals negative 8, 6B minus 3C equals negative 6. Now, as you can see, this is not in row echelon form yet, but it's very close. And I think that'll become more apparent with the next step. Okay, so we can switch row 2 and row 3. At any time while you are solving a system, you can always switch rows. You can swap them because mathematically it doesn't matter what order they're written in. But sometimes it helps us as human beings just to see things a little more clearly. So we're going to switch row 2. And we end up with this system, negative 4A plus 4B minus 4C equals negative 12, 6B minus 3C equals negative 6, 8B equals negative 8. Now, again, this is not in row echelon form yet, but as you can see, it follows a pattern that's similar to row echelon form. And that is the following. In row echelon form, the first row has 3 variables, the second row has 2, and the third has 1. Well, that pattern is apparent here. Now, normally in row echelon form, we like to get the third variable, z or c in this case. We want to get that third variable alone in the third row. But as we can see in this system that we've ended up with, we are getting the second variable, in this case b, by itself in the third row. And that is actually going to be just as solvable, because if you get one variable by itself, you can solve for it, and then you can use back substitution to get the other variables. So we're going to do that here. We can jump right to straight to step 4. And step 4, as you remember and as you can refer to in your previous notes, step 4 of Gaussian elimination is just multiplying by constants. So we're going to multiply row 1 by negative 1/4, row 2 by 1/6, and row 3 by 1/8. And we end up with A minus B plus C equals 3, B minus 1/2 C equals negative 1, B equals negative 1. Again, not exactly in row echelon form, but it's in a pattern that really matches the basic pattern of row echelon form. And therefore it's solvable. We already have B. We can back substitute that into row 2 to find C, and then we back substitute B and C into row 1 to find A, and we end up with this solution. 2, negative 1, 0. A equals 2, B equals negative 1, C equals 0. All right, now let's answer the original question. We want to know the curve that passes through the 3 points that were given on the last screen. And that curve, that quadratic equation, has this form: y equals ax squared plus bx plus c. Well, we found a, b, and c using Gaussian elimination on our multivariable linear system. And therefore, we can fill in a, b, and c here. Y equals 2x squared plus negative 1x plus 0. And that simplifies, of course, to y equals 2x squared minus x. And that is my quadratic equation that passes through the 3 points that were given on the last screen. Now we're going to talk about investments, and we'll do a word problem. $12,000 is invested in 3 funds, one at 5%, another at 6%, and another at 12% interest, not compounded. The amount invested in the 12% fund was $4,000 more than the amount invested in the 6% fund. The total interest each year is $1,120. How much is invested in each fund? So we're going to translate this English word problem into mathematical equations. There will be 3 equations. Pause the video, try to get those 3 equations on your own, and then resume. So here are the three equations. X plus y plus z equals 12,000. We know that the amount 12,000 is spread out over three different funds, and so x plus y plus z equals 12,000. The next equation, 0.05x plus 0.06y plus 0.12z equals 1120. We know that because we know that the total interest each year is $1,120. And finally, z equals y plus 4,000. We know that because the amount invested in the 12% fund, which is represented by z, was $4,000 more than the amount invested in the 6% fund, which is represented by y. So z equals y plus 4,000. All right, these are three equations. As you can see, it doesn't quite look like a system yet, but we can change that easily by simply rewriting row 3. So we have x plus y plus z equals 12,000, 0.05x plus 0.06y plus 0.12z equals 1120, a negative y plus z equals 4,000. And finally, this is just to get you started in the right direction. I'll do step 1 of Gaussian elimination for you here, because step 1 is often overlooked, and it's simply that you can always swap rows. Why do we do that? Because it looks better visually, and it helps us to see where we need to go in order to get row echelon form. Okay, so what I did here is I simply swapped rows 2 and 3. And why did I do that? Well, I did that because, as you know, the goal in Gaussian elimination is to get only one variable by itself in the third row, 2 variables in the second row, and 3 variables in the third row. Well, doing this swap basically makes our rows 1 and 2 already in row echelon form. So we can see that all we need to do now is eliminate the x term and the y term in row 3. Okay, at this point we've walked through enough examples so that you should be able to do this on your own. You should be able to do the rest on your own. You want to get this system into row echelon form using the 4 steps of Gaussian elimination. I already did step 1 for you. So pause the video, do this on your own, and resume when you have an answer, or, of course, if you get stuck. Here's the answer. X equals $2,000, Y equals $3,000, Z equals $7,000. That means that $2,000 are invested in the 5% fund, $3,000 are invested in the 6% fund, $7,000 are invested in the 12% fund. Here's the classwork, page 529, these 6 problems. Please copy those down and get a head start if you wish before class. And that concludes section 7.3.